This video is on circles. Recall from geometry that a circle is the set of all points in a plane that are equidistant from a given point, that given point being the center. The segment from the center to any point on the circle is called the radius. So here we have a picture of a circle. Notice that our center is the coordinates hk, x and y are any point on the circle, and that distance from the center to the point on the circle is the radius. Recall also from the previous video that a circle is what you get when you intersect a double cone with a plane that is parallel to the base of the cone. Standard form of the equation of a circle is x minus h squared plus y minus k squared is equal to r squared, where the center is hk and the length of the radius is r. And if you recall from geometry, this is basically based on the distance formula. How far is the center from any point on the circle, and that distance is going to be constant. So let's take a look at a couple examples here. First of all, we need to write the equation of the circle that has its center at -3, 1 and has a radius of 4. So the x-coordinate of my center is going to be h, the y-coordinate of my center is going to be k, and my radius is going to be r. So my equation is x minus h squared plus y minus k squared is equal to r squared. So plugging in those numbers, x minus a -3 is going to give me x plus 3 squared plus y minus 1 squared equals r squared, which is 16. So the quantity x plus 3 squared plus the quantity y minus 1 squared equals 16 is the equation of a circle that has a center at -3, 1 and a radius of 4. Next example says to identify the center and the radius of each of these circles and then to graph. So here we have the quantity x minus 3 squared plus y squared equals 16. So h is whatever's being subtracted from x. So h is going to be 3. K is whatever's being subtracted from y. Nothing's being subtracted from y, so k is equal to 0. And 16 is equal to r squared. So my r is going to be 4. So my center is the point 3, 0. My radius is 4, and from that I can graph. So let's graph the point 3, 0, which is right there. And my radius is 4, which means from the center I'm going to go up 4 units, to the right 4 units, to the left 4 units, and down 4 units. And try to draw this so it looks kind of like a circle. So the center and radius of the circle whose equation is x minus 3 squared plus y squared equals 16. The center is the point 3, 0. The radius is 4, and this is what the graph of that circle looks like. And our last example has the equation of the circle written in general form. So I have x squared plus y squared minus 4x plus 8y minus 29 equals 0. So just looking at that, I cannot identify h and k. I don't know what my center is. I don't know what my radius is. But I can rewrite this so that I can do that. So first thing I want to do is group together my x terms. So x squared minus 4x. Group together my y terms, y squared plus 8y. And then move my constant term to the other side of the equal sign. Now what I want to do is complete the square. So rewrite x squared minus 4x as a perfect square trinomial so that I can factor it into a binomial squared, and then the same thing with my y's. So in order to turn this into a perfect square trinomial, I need to add 4 to there, so then that will factor into x minus 2 squared. Go back and review completing the square if you need to. For y squared plus 8y, I need to add 16, and that will factor into y plus 4 squared. And since I added 4 on this side, I need to add 4 over here. Since I added 16, I need to add 16. So that's going to give me 49. So now my equation is written in standard form as opposed to general form, and I can identify my center as the point 2, negative 4, and my radius is equal to 7. And from that I can graph. So 2, negative 4, and then my radius is 7, so I'll go 7 units up, 7 units to the right, 7 units to the left, and 7 units down is going to put me off the graph, but that's okay. And then connect that. And that's not a very good circle, but you get the idea. So in this video we took a look at circles, how you get a circle by slicing a cone, what the standard form of the equation of a circle is, and from that how to identify the center and the radius and how to graph. We also took a look at how to turn equation of a circle in general form into standard form so that we can identify the center and radius, and how we used completing the square to do that. If that was a little confusing, go back and review how to complete the square.